Sorry, I'm gonna leave. I'm driving so far. Tell me why you coming to me and say you want me again. Never wanna lose me, 'cause I'll be missing.
Patterns in nature have existed throughout the creation of the universe.
Yes, and you can always observe all around the world. But I always thought that it is just random stuff. Some may be even a coincidence.
No, it's not random. It's actually math in action. Now let's explore how these patterns relate to math and how it shapes the world. By the end of this video, we're going to identify the different patterns in nature and how math affects these patterns.
And we are going to describe these patterns too, right?
Yes, of course. And also, we'll give examples for us to understand.
So let's go. Let's get started.
Firstly, we have symmetry, refers to a sense of balance and proportional similarity in the arrangement of parts on either side of a dividing line or around the center. Bilateral symmetry in the creeping Charlie plant refers to how its leaves can be divided into two equal halves along a single plane. Also, the leaf structure of a dam cane can be divided into two equal halves along its central vein. Fish also exhibits bilateral symmetry as you draw an imaginary line in half. It would result in a mirror image of the left and right sides.
A spiral is a curve that emanates from a point, gradually moving away or towards it in a circular pattern. The spiral of the snail gets wider as the shell grows, but the shape maintains a consistent proportion. Millipedes use spirals for protection, movement, and growth, making them an example of a common natural pattern. Meanwhile, this plant also exhibits a spiral pattern that gradually moves away in a circular pattern.
Fractals are irregular patterns made up of parts resembling the whole structure. The way the branches branch out from the trunk creates a similar pattern of branching structure.
Tessellation is made of one or more geometric shapes called tiles that fit together perfectly without gaps or overlaps. This is a rock surface with a repeated pattern. The surface appears to have formations that create a continuous pattern, and these patterns covers the surface seamlessly, meaning the pieces fit together perfectly like a puzzle. Fish scales fit together in a repeating interlocking arrangement without gaps or overlaps.
Meander is characterized by sinuous curves, bends, loops, turns, or winding patterns. The curving stem or vine exhibits meandering growth in which they grow in a wavy pattern. A river also develops a meander pattern due to the interaction of water flow from one place to another.
Stripes are made up of a series of bands or strips. The stripes appear as alternating light and dark bands running horizontally around this bamboo. This is also a piece of bamboo with dark bands that also runs horizontally.
A wave is a disturbance that transfers energy through space or matter that is characterized by oscillations or fluctuations around the central point. When fish come close to the water surface, either for feeding or breathing, their fins or bodies can break the surface tension, creating ripples that spread outward, causing the surface of water to move in an oscillating pattern.
Foam refers to the substance formed when gas gets trapped in a liquid or solid. When fish swim, feed, or splash, they disturb the water surface, trapping air and forming foam.
Cracks refers to the displacement, discontinuity, or separation of an object or material due to an action of stress. Rocks in a tree can form due to natural growth processes, environmental factors, and internal stresses.
I see it's not just random coincidences.
In fact, everywhere we go, matters influence us on this pattern, from branches of trees to the bodies of water.
I think I might have to appreciate the nature more considering it's not random. These are just examples, when in fact patterns are all around us. But always remember, it's not just patterns that happened randomly. Math takes actions in between to consider what we call randomness. Till next time guys, see you!